Let's walk through the 6.2 assignment and see if I can give you some tips to help you out. So you got a couple like these where you need to find the circumference of a circle. The important thing is to take note of that on these problems we're using 3.14 for pi. Okay, if you hit the pi key on your calculator, your answer might come up a little bit different and it'll count it wrong. And so just estimate pi here at 3.14. Also with circumference, if you look through the list of the formulas, and so that'll be, you need to write down all the formulas you get out of instruct or out of learn mode, okay? And when you look through the list of formulas, there's two versions for circumference. One is 2 pi r, and the other one is pi d. And so the r and the d, r is the radius of the circle. That's if you have halfway across from the center out. D would be diameter, and that's if it gives you a measurement all the way across. Okay, so you can use either formula anytime, but you just have to realize if you have the radius and you want the diameter, you have to multiply it by 2. If you have the diameter, you want the radius, you can divide by 2. Okay, or you can use the matching formula, either one. So on this one, I would do 2 pi r. So I would do 2 times 3.14 times my radius of 13 and get my answer down here. Okay. I think number 2 is the same type. Yep. Okay. Number 3 says find the sum of the measures of the interior angles of a 38gon. That's a 38-sided polygon. So there's a formula for this one, okay? And once you get the formula, it's an easy little problem. The formula is n minus 2, so sides minus 2. So we've got 38 sides here. So if we subtract 2, that would be 36 times 180 degrees. So for this problem, we would do 36 times 180 degrees and get our answer here. So having the formula is the important part on that one. Okay. This one I want us to work through. Okay, it says we're going to create a canvas cover for the pool. How many square feet of canvas would be required? So if it says square feet, that means we want the area. Okay, so you can do this problem with the area of a trapezoid formula, but that's not how I like to do it. And I like breaking it up into a rectangle, into a triangle, and just adding those two answers together. So let's see, we've got 12, 14, and 15 are our sides here. So let's see if we can sketch this out. Okay. Let's see. So we've got a triangle, and then we also have a rectangle. 12, 14, 15. Sorry, this drawing's so terrible. Okay, so on this one, what I'm going to start with is I'm going to start with the area of the rectangle part. So for area of a rectangle, it's length times width. So here I'm going to do 14 times 15. Okay, so let's see, 14 times 15, I get 210. And that's the easy part. And then we've got, this is a right angle, I didn't draw that in, but then we've got this triangle over here. We can find the area of this triangle. And so for the area of a triangle, it's 1/2 times the base times the height. Okay, here, so we've got 1/2 times the base, which is 12, times the height, which is 14. On that one, I'm getting 98. So then we can add these two areas together. What do we get there? Get an area of 308, and I'm thinking it was square feet, but we'll check it. 308 square feet, I believe. Yes, 308 square feet. You can do it with a trapezoid formula, but I just prefer to do it in two pieces. That way I don't have to deal with the trapezoid formula. Okay. And on this one, another thing to point out is you really have to be careful reading to make sure you know what you're finding, not just guessing what you're finding. Like you might think this one wants circumference because it's like the other circle problems we had, but it's not. Okay, it says how many square centimeters of paint would be required to cover the top surface here. So since it says square units, we want the area. And the area of a circle is pi r squared. So we're using 3.14 times r squared, so times 10 squared. And that will give us our area in square centimeters. So just be careful reading these two. It's really frustrating if you do the right calculation, but it's not what it was asking for. And on this one, we've got a rectangle. It gives us the dimensions. It says find the area of land to be enclosed. So area of a rectangle is just length times width. So we would just multiply these two numbers to get our area down here. 7. It looks like the last one we worked out. Okay, but on this one, again, you have to read carefully. It says they want to build a fence around the perimeter of the pool. So how many feet of fencing is required? So it's not square feet. We don't want area. We want perimeter. Okay? So we've got 16, 18, and 17 are our dimensions here. Let's see if I can draw a little better this time. Triangle and then a rectangle. It's not much better. And I forgot 16, 18, and something. 16, 18, 17. Okay, so now we got to figure out the distance around the outside. So we want all of these sides and we want to add them together. Okay. So we go to the top up here, I'm looking at this side, then it has to be the same as the bottom of the rectangle, right? Because they're across from each other, so that has to be 17. If we go to the right side, it's a rectangle, so that has to match the left side, so this one will be 18. And then we've got these two on the bottom that we can add together. Right? But we're missing a piece, and the piece we're missing is this side over here. Again, this is a right angle. So we can do Pythagorean theorem to figure out that side. So the two legs, if we do Pythagorean theorem, the two shorter sides are the 16 and 18. The one across from the right angle is the C, or the longer side, the hypotenuse. So to figure out that side, it's going to be 16 squared plus 18 squared. That will give us C squared. So let's see. 16 times 16 is 256. 18 times 18, 324. So if we add those together, we'll get C squared. So that's 580. And now we're going to take the square root. Square root of 580. 24.08. We round to 2 decimal places, and that is going to be C. Okay. And so this side is 24.08. And then if we add all these together, 24.08 plus 16 plus 17 plus 18 plus 17, get a perimeter of 92.08. And I'm guessing it tells us to round to the nearest hundredth, so 92.08 is what we would put in there. Okay. So we just to make sure we're clear here, the numbers I added, okay, we added this one, this one, this one, this one, this one, right? The outside numbers. You don't have to add the 18 on the inside. So we want the perimeter. Okay. All right, this one will get Pythagorean theorem involved again. It says how many square feet of landscape fabric. So square feet, we want area. On this one, I like to kind of think about rotating this. So I'm going to make 15 the bottom, just so it's a little easier to look at. And then the long side will be 17. So if we do that, then we've got 15 down here, and then this longer side will be 17. And to get our area of a triangle, we got to have a side that's going straight up and down for H for our height, and you can't have a slanted side for your height. So that means we have to figure out this side over here. So again, we got to go back to Pythagorean theorem. And so we've got some side, we'll call this side A. And some side squared plus our other side, 15 squared, equals 17 squared, the long side squared. Okay, so we got A squared plus 225 equals, let's see what 17 squared was again, 289. So if we subtract 225 from both sides, we can figure out that our side squared is 64. So if we take the square root, A is 8. This side up here is going to be 8. And now we just plug into our formula. So for area, it's 1/2 times the base, which is 15, times the height that we just found is 8. So this one will be 60 square units, but I don't remember what the units were. They were feet, so 60 square feet here. Square feet on that. So you have to do the Pythagorean theorem to find the missing side, and then you can find the area. All right, so this one, we have a rectangle. We want to figure out how much fencing we need to go around to get the perimeter. So since it's a rectangle, it says it's 700 by 200, so it'll be 700 plus 200, and then what about the other two sides? They're also going to be 700 and 200, so 700 plus 200 plus 700 plus 200. And just add them all together. Number 10. Okay. So we've got a building, and we're also going to place a 2-meter tall model of the building down on the ground beside it. And so it says the model is 2 meters tall. The shadow of the model is 1.2 meters. And so we're going to make a little triangle here. The sketch really helps on this one. So we've got a model that's 2 meters tall, and the shadow coming out from our 2-meter tall building is 1.2 meters tall. And we're placing that by the big old building up here. And we're going to figure out that the shadows match up. Not doing very good drawing tonight. The shadows match up. And it tells us the shadow of the whole building is 306 meters. So if we think about the shadow of the whole building, that's 306 meters. And it's asking us how tall is the building, or how tall is this side. So what we've got is we've got a triangle here. We'll move that over here, okay? We've got a triangle here we're dealing with, and again, it's really ugly. I'm sorry, I need a ruler, I guess. Okay, so what we can do is we can set up a proportion because we've got a little triangle inside this bigger triangle. So what I want to do is I'm going to take the height of the small triangle, 2 meters. Now I'm just going to write 2, over the length of its shadow, 1.2. That has to be proportional to the height of our building, which we don't know. I'll call it x, over the length of the shadow of our building, which is 306. Okay. And then we cross multiply. So 2 times 306 is 612. And that has to be equal to what we get when we cross multiply the other way. So 1.2 times x is 1.2 x. And then we divide both sides by 1.2 to solve for x. So that cancels. And then 612 divided by 1.2 gives us 510. How tall is our building? It's 510 meters. Sorry, my drawing was so ugly. Let's see, one more here. This one looks terrible, but it's not that bad. Okay. So the first thing we need to know is we need to know if we add all these angles up, it gives us all these different representations. If we add all these angles up, what's the total going to be? So we got to count the sides. 1, 2, 3, 4, 5, 6 sides. Okay, so we can go back to our sum of interior angles formula. At the n minus 2 times 180. We have 6 sides, so 6 minus 2 give us 4. We'll do 4 times 180 degrees. That gives us 720 degrees. Okay? So this is going to be the total when we add all these angles together. So that's going to be our total. Now we need to figure out how we get there. The way we get there is we take each one of these pieces and we add them up. And so we've got 125 plus 120 plus x. I have to do them 3 at a time. So 125 plus 120 plus x. We'll add the other 3 angles. So x plus 15 plus 95 plus x plus 20. So x plus 15 plus 95 plus x plus 20. And my short-term memory is not good, so I'm going to double check myself. X plus 20 was the last one. That's right. Okay. So what are we going to get when we add all these up? We're going to get 720. That's our total. So this is 720. Now we're just combining a lot of like terms. So we've got 1, 2, 3 x's. Plus, then we add the numbers up. So we're going to add this together. And we're combining like terms. So 125 plus 120 plus 15 plus 95 plus 20. And I got 375 there. And what does that equal? That equals our total degrees of 720. Now we do 720 minus 375. 720 minus 375 give us 345, so 3x is 345. Divide both sides by 3. 345 divided by 3 tells us that x equals 115 degrees. So now that's not our answer. It might be part of our answer. It's not the whole answer. We know the x degrees is 115 degrees. So when we go back to Hawks, well, that is the first part. So x degrees would be 115 degrees. Sorry about that. Okay. Then what about this next one? X plus 20. Well, that's 115 plus 20. So that one's going to be 135. And then 115 plus 15. That will be 130. So you figure out x, and then you can figure out these other little pieces here. Okay? Let me know if you have questions.